Okay, so we've learned all this algebra, solving equations, proportions, formulas, and all that stuff. The next step, the part everybody loves, is to start looking at problem solving and word problems. Most of what we do in here from here on out is going to come down to some sort of a word problem. So we're going to have to get good at picking information out of that problem and selecting the correct strategy to solve it. Now, in some cases, like the problems we just looked at, we're going to have formulas that fit that situation. For example, if we are told that Pete earned $160 in interest on an investment over 2 years at 4% interest. How much was invested? I apologize. At this time of night, my handwriting tends to get really sloppy. Anyway, our formula that we gave for this was a simple interest formula. I equals P times R times T. So, the 160 is the I. Do we know P? No, we're looking for how much was invested. The principal is what we're looking for, P. Do we know R? 0.04, the 4%. Do we know T? 2 years. Very good. Now to solve this, just like any other equation, the first thing we have to do is combine anything that we can on either side. Now over here we just have the 160, so there's nothing to combine there. On the other side we have 0.04 times 2, which is going to give us 0.08. Then what? We're going to divide by 0.08. So here we have P. On this side we get $2,000. Or we may end up with a problem like Sam earned $90 on a 3-year investment of $6,000. Find the rate. So same formula. I equals P times R times T. I again is the amount of interest, which is $90. P is the principal or the starting amount. In this case, that is, careful, 6,000, right? Times R is the rate. In this case, that's what we're looking for. That's our variable. T is time. And in this case, that is 3. So to solve this, we're going to start out by combining again what we can combine. Hey guys, a little loud. So we're going to combine the 6,000 times the 3 to get 18,000. And from there, we'll divide by 18,000. So R is 0.005. If we wanted to, if you left it at that, that wouldn't be incorrect. But if we wanted to convert that to a percent, it's 0.5%. which actually sounds like pretty decent interest to me right now on most of my accounts. You could try. You're not in accounting, are you, Cody? Just kidding. Okay. Other applications we can come into. What's that? So I think I'm getting like 0.08% on some of it, or 0.2 on some of the best of it. That's not real healthy. So anyway, let's look at another application. We talked about straight line depreciation, where the amount of depreciation is equal to cost minus the scrap value over the life of the item. So let's say that we need annual depreciation for an item is $7,000. It cost $69,000 and is expected to last 8 years. What is the anticipated scrap value? So for our formula, do we know D? 7,000. Do we know the cost? 69,000. Do we know the scrap value? No, that's what we're looking for. Do we know the useful life? 8 years. We better know the useful life because we only have one unknown. Now from here, looking at this equation, there are actually a lot of things that have been done to our variable s. Sometimes when you have an equation like this, the simplest way to solve it is to do it like the last type of equation we were looking at and turn it into a proportion, like this. If that's the way you prefer to do it, go ahead. I'm going to go ahead and I'm going to solve this brute force just to show you how to do it. Now what's been done here, first of all, you can see this whole side of the equation has been divided by 8. So we're going to multiply by 8 to get rid of that. So that's gone. Over here, 7,000 times 8 gives us 56,000. Now on the right side over here, we run into an issue that causes a lot of mistakes, and that's why I wanted to go through it this way. The 69,000 is not subtracted from S. The S is subtracted from the 69,000. There are a couple of ways we can approach that, but the simplest is to view it as this. That this is 69,000, and this is a negative 1 times S. So to solve this, we have to get rid of the 69,000. It's a positive 69,000, so we will subtract it. So that's going to give us a negative 13,000 over here, equals a negative 1 times S. And now we're going to divide by negative 1 to get that S is $13,000, a scrap value of $13,000. You look confused, Cody. What? You look confused. Oh, you good? Okay. Unfortunately, we don't always have problems that have a set formula to use. So we're going to have to use what we were talking about at the beginning of class, where we're picking the information out and figuring out our operations from there. Now, some of our simpler word problems and some of the ones you will see in my math lab are so simple that it's hard to write a formula for them. So the next couple of examples are going to fall into that category. Let's say you plan to save 1/15 of each check for retirement. Let's say in a certain week, you save $48. How much was your check? Now, like I said, some of these simpler problems, you look at it and you very quickly know how to get the answer, so it's hard to go back and write an equation for it. So for one like this, I'd look at it and it's pretty simple for me to see that it's just 48 times 15 is going to give me my answer. But a lot of times my math lab is going to ask you put in the equation for this. So first thing I have to do is I have to set up some variables and define them. So I'm going to put the amount of my check. I'm going to either put it as C for check or P for pay, however you want to do it. My retirement, then I'll put it as R for my retirement savings. So what this is telling me is the amount of my retirement is going to be 1/15 times the amount of my check. So 1/15 times my pay. So there's my formula. Again, just taking the words out of the question and trying to put it into an equation. Now I am given that I saved for retirement $48. That's going to go in for R. To solve this now, it is P times 1/15. So I'm going to divide by 1/15 or multiply by 15, however you want to look at it. And get that my pay had to be $720. Does that come out right? Again, like I said, that's one that I would look at. I would not write out a formula if I were doing that. I would see how to do it and just multiply it out. Let's say that you have sold $3,381 worth of merchandise. At $23 per item. How many items were sold? Okay, well, once again, this is one where I'd look at it and you can see that you're just going to take the total sales divided by 23. But how would we set that up? Well, this actually does have a formula if you want to dig deep. Revenue is going to equal your sales times your price per sale. So we have revenue of $3,381. Our number of sales is what we're looking for, and our price per sale is 23. How are we going to solve that? Divide by 23. So we get that our sales equals $147. So we sold 147 items. We can also run into problems that are rates or relationships, like our proportions. If we're told in a 28-hour week, you earn $364. How much would you earn in a 32-hour week? Okay, well, it's a similar. Well, this one is actually, we're looking at a rate here. $364 in 28 hours would give us our pay. And we could divide that out to get our hourly pay, but we can save ourselves a step. Our pay for 32 hours would have to be the same rate. And since this is now going to be two equal fractions or two equal ratios, we can do what we were talking about earlier, and we can cross multiply. So in this direction, we have 32 times 364. In the other direction, we have 28 times P. So 32 times 364 is 11,648. And then divide by 28. 416. So you'd make $416 if you work 32 hours in a week. Let's step up to something a little bit more difficult. Like I said, those first few, I wouldn't need an equation to solve them. I would just look at them and do whatever operation is necessary to find the answer. But we can find something a little bit more complex, like, let's say that Frank sells 3 times as many t-shirts as sweatshirts. If a total of 128 items were sold, how many of each were sold? When we're dealing with problem solving like this, when we get to be a little bit more difficult problems like this one, there are a few things we're looking for. We're looking for either two things that add up to make a total, or we're looking at two things that subtract to make a given difference, or the third option is we're looking for two things that are equal to each other. Now in this case, we are given a total. So that implies that we are looking for two things that add up to a total. And in this case, the two amounts that we are looking for are the number of t-shirts and the number of sweatshirts that are sold. So I'm going to start by charting that out. One of the things that we have to do next then is define our variable. And we can use whatever letter we want to, A, B, C, X, Y, T, whatever. But we have to assign it to one of those items that we're looking for. But we have to be careful to do it in such a way that we can define the other item with that same variable, because we don't want to get into equations with two variables in them. So what we do is we look up here and we try to find if one value is defined from the other. And here we can see it says 3 times as many t-shirts as sweatshirts. So that's telling us is if we knew how many sweatshirts were sold, we could just multiply by 3 to get the number of t-shirts sold. So for my variables, I'm going to let the number of sweatshirts sold be X, which means the number of t-shirts sold would be 3x, 3 times x, because there's 3 times as many. Now that I have them defined, I know that we're looking at a total. The number of t-shirts plus the number of sweatshirts totals 128. So we have 3x plus x equals 128. What do we do with that from there? So 3x plus x, and like you said, that's 3x plus 1x makes 4x equals 128. And then divide by 4. X equals 32. Now, it's really tempting at this point to say, hey, I solved for x, I'm all done. But I'm not. I still have to answer the question. The question asked how many of each were sold. X is the number of sweatshirts. So that means there's 32 sweatshirts sold. We still have to find the number of t-shirts, which means we have 3 times x, or 3 times 32, gives us 96 t-shirts sold. That's also one of the reasons why I write this out, is so once I get that answer, once I find out what my variable equals from the equation, I first of all know what the variable represents, and then I also know how to find the other amount from that same variable. We might have that Pat sells 200 more cars than trucks. In a year where 800 total vehicles are sold, how many of each are sold? So now in this case, again, are we looking for a total? Are we looking for a difference? Or are we looking for two things that are equal to each other? Looking at a total. 800 total vehicles. So we have the number of cars and the number of trucks. Now again, we want to look to see if there's a relationship where one can be defined off the other. It says 200 more cars than trucks. So what is that telling us? If I let x be one of them, first of all, which one of them would I want to let x be? Number of cars or number of trucks? Number of trucks. Because then the number of cars is going to be not times, but plus 200 more. So x plus 200. Once we have that, now we know the total is 800. So if the x plus 200 plus another x equals 800 items, 800 vehicles in this case. Now what do we do? One x and 1x make 2x plus 200 equals 800. From there we subtract 200. 2x equals 600, and then divide by 2. So now that we have that x is 300, how do we use that to answer our question? So we've got 300 as the number of trucks, and you're right. To find the number of cars, it's 300 plus 200, or 500 cars. And we can always double check. 500 plus 300 does give us 800 total. Let's say that Steve sells 3 times as many cars as Tim. If Steve sells 284 more than Tim, how many does each sell? So now in this case, we're looking at the number that Steve sold the number that Tim sold. And again, we're looking at, does one of them reference off the other? If I know one, is it easy to find the other? Well, we do have that relationship. Steve sells 3 times as many as Tim. So which one do I want to let be my variable? Tim or Steve? Tim. And I can use X and whatever. I'm going to use T for Tim. What's Steve going to be then? 3T, because he sold 3 times as many as Tim. Now in this case, are we adding up to a total? No. We're told that Steve sold 284 more than Tim. That's giving us a difference. We're looking at the amount that Steve sold minus the amount that Tim sold is 284. But we know from what we defined our variables, the amount that Steve sold is 3T. The amount that Tim sold is just T, and that's going to equal 284. What do we do from there? You got it. 3T minus 1T is 2T equals 284. And divide by 2. So T equals 142. What do we do from there? Perfect. So Tim sold 142. Steve sold 3 times 142, or is it 426? And if you wanted to, you could double check by subtracting, and it should come out to 284 is the difference. How are we doing? So about 10 minutes ago, I felt the energy level in this room just like bottom out. We'll try to make this quick and get you out of here. Okay. Let's make these a little more complicated. Let's go back to clothing again here. Let's say that Pat sells shirts for $16 and hats for $8. If $176 is raised from selling 16 items, how many of each is sold? This one's actually quite a bit more complex than the last couple we've solved. So we're looking at number of hats and number of shirts. And I'm going to start out by defining the number sold. Because that's what we're looking for, is the number of each that are sold. Is there a relationship between the number sold here? And we've not told anywhere that one of them is a certain number times the other. And we're also not told that one of them is a certain number more than the other. But we are told there's a total of 16 items. So, let's put that. If we have hats plus shirts is going to equal 16. But that would give us 2 variables, and we can't work with 2 variables. So let's let let's do this. Let's let H be the number of hats sold. How many shirts would be sold then? Perfect. If I wanted to solve this for S, I would subtract H. So the number of shirts sold is 16 minus however many hats are sold. Now the total we're given, this is a total, we're going to add up the money from the hats and the money from the shirts to get 176 bucks. The problem is, this isn't dollars, it is numbers. It's the amounts. How do we convert those into dollars? Well, the shirts were sold for $16 each. So I'm going to multiply the number sold by 16. Hats were sold for $8 each. So I'm going to multiply the number sold by 8. So H times 8 is 8H. Plus, I'm going to put the 16 out front here. So 16 times 16 minus H has to equal the $176. What are we going to do next here? Well, we have parentheses, which screams at us that we have to do something there first. Is there anything to do inside the parentheses? No. But we do have something we can do to the parentheses, times the 16. So we're going to do 16 times 16 is 256. 16 times negative h, or negative 1h, is going to be negative 16h. We still have the 176 there, and we still have 8h over here. Now we go to combine. On the left side, we have 8h and negative 16h make negative 8h plus 256 equals 176. What do we do from there? Subtract 256. Negative 8h equals 176 minus 256 is a negative 80. And then divide by negative 8. So h equals 10. So what's that tell us? 10 hats and 16 minus 10, or 6 shirts. Perfect. Let's do one more example and get you guys out of here. So let's look at Chris. Sells shorts for $7 and shirts for $12. He sells 4 times as many shirts. As shorts. The total sales are $515. Again, how many of each were sold? Did I do that right? I'm going to change this to make this work better. Let's make that $550. That'll work better. So again, we have number of shorts, number of shirts. Can one of them be defined off of the other? Yeah, this one's a little simpler. It flat out says 4 times as many shirts as shorts. So which one's going to be X? Shorts. And the shirts will be 4X, 4 times as many. But again, we are given a dollar amount total of $550. So we have to convert these into dollar amounts. How are we going to do that? Well, how much is it per pair of shorts? $7. So the dollars from shorts will be 7 times X. Dollars per shorts times the number sold. How about for the shirts? So it'll be $12 times $12 each times 4X, which is going to give us 48X. You're correct. So we have 7x plus 48x equals the $550. What do we do from there? We're going to add 7x and 48x to get 55x. And then divide by 55. X equals 10. Now, of course, we've got to go back and answer our questions. The 10 is the number of shorts. There's 10 pairs of shorts. Shirts would be 4 times X, or 4 times 10, or 40. I can see you guys have had enough. So, there is a new quiz due now. It'll appear out on MyMathLab now when you go into it. That will disappear tomorrow, Wednesday, at 11:59 p.m. Now, since this is the first one, and I understand some of you are having problems getting into MyMathLab, let me know, and I'll extend it for you if we have to get this first one done. Now, just so you know, the quiz, and when you did the homework, you had all those helps, like show me an example, or help me solve this, or ask my instructor. On the quiz, you will not have those helps. You won't be able to check your answer after each question. You'll have to answer the questions and go through, and it'll check your answers at the end. So once you hit submit, it'll tell you your score, and then you can go back through and look at them and see the ones you got wrong and see what you did. You do get 2 attempts on a quiz. So if you do it once and you don't like your score, you can try it again. Now, the system will automatically take your highest score. So even if you do fairly well on the first attempt, unless you get them all correct, you have nothing to lose by going ahead and do, well, you have nothing to lose either way, but if you get them all right, why would you want to do the extra work, right? But, so there's nothing to lose. If you do it a second time and you do worse, the system will still take your highest score. There is a 2-hour, or actually 120-minute, which is the same as 2 hours, time limit. So just so you know, don't start it and then run off and do something and leave the computer up. It'll time you out. If that happens, let me know and I can reopen it for you, but it's easier if you avoid it. The 2 attempts are not per question, it is per quiz. So if you can't go back and answer individual questions, you have to redo the whole quiz over, just so you know. Then there's also a new homework. It'll be due next Tuesday. Any questions? That's a good question. We can look that up quick. If I can type, maybe we can look it up quick. So to get into the quiz, since we're in here, I'll walk you through it. On the left side here, so I gotta shut off. The homework button is there. That's where you got into the homework. Well, below it is the quizzes. Up until now, that button hasn't shown anything other than the 4 tests. You'll see now that quiz 1 does appear there. If you open that up, there's 8 questions on this quiz. So it shouldn't overstress you too bad. It'll give you this asking you, are you sure you want to go into it? And if you've done the homework, you should be ready for the quiz. Just hit yes, I am ready to start, and there you go. You'll notice none of those helps are over here like we had before. Any questions? Okay. The computer lab down the hall here is open, and I'll be down there to help you if you want to work on it. Those of you in New Richmond, if you either have a laptop with, or if you want to, I think all the computer labs are probably closed there now, but if you want to work, I'll be bouncing back in and out from the computer lab to this room if you have any questions that you need help on. Otherwise,